This is the Forces and Motions Modified quiz. This will be your last quiz of the year, so good luck. Number 1. A cat is falling from a tree. What can you determine about the forces acting on the cat? Looking at the free body diagram below. Is the forces are balanced? B, the forces are unbalanced? Or C, there's not enough information available? So they're asking you to look at these arrows and determine if A, the forces are balanced, the forces are unbalanced, or C, there's not enough information available. 2. Identify the two forces that are acting on the falling cat described in number 1 above. Choose 2 from the following list. So, we're looking at what we would label this top arrow and what we would label this bottom arrow. You wouldn't use one of these both. So there's 2 of these out of the 4 that you would use. Would you label one gravity, applied, normal, or drag? And would you label the other one gravity, applied, normal, or drag? 3. Predict the motion of the object shown in the free body diagram below. So let's look at the free body diagram below. Look how the arrows are pretty much equal in length. All equal in length. So, A, the object must be moving to the right due to the applied force. And this one is labeled applied force. B, the object must be falling down due to gravity. There's gravity, but there's also a normal force up here. C, the object's motion is not changing. It's at rest or going at a constant speed. You'll have to determine if the arrows are equal. 4. Assume that all the forces acting on the object in question number 3 are equal. What is the net force in newtons acting on the object? So if each one of these arrows are equal in magnitude, saying that this one is equal to 10 newtons and this one's equal to 10 newtons, friction is equal to 10 newtons, and gravity is equal to 10 newtons, they all add up to what? Number 5. If a person is pushing a box forward, which forces are acting on the object? So if a person is pushing on the box forward, which forces are acting on the object? Is it A, just gravity and normal forces? Is it B, gravity, normal, and friction? Or C, gravity, normal, friction, and applied? Number 6, draw a free body diagram of a car moving after a stoplight has just turned green. Include all the forces acting on the object, including their strength and direction. So you're going to draw a free body diagram of a car moving after a stoplight just as it turned green. Include all of the forces acting on the object, including the strength and direction. So remember, the first question we always ask ourselves after we have a free body diagram asked for us to draw is whether or not this is a balanced or unbalanced free body diagram. Think about it. Is a car going to accelerate, slow down, be at constant speed, or stopped after the stoplight has just turned green? So write somewhere on here whether or not that's balanced or unbalanced. Now think about each force. Is there a normal force acting on the car? Is there a gravitational force acting on the car? Is there an applied force acting on the car? Is there drag acting on the car? Is there friction acting on the car? Make sure you ask yourself that each force that could possibly be on that car as it is taking off from that green light. Number 7. After the driver of the car sees an upcoming light turning yellow, they begin to slow down. As the car slows down, predict the nature of the forces. So this is slowing down. There's a key word there, and when you see the word slow down, that means the forces are either balanced or unbalanced. So slowing down, is that balanced or unbalanced? So A, the forces will be balanced because the car is decelerating. B, the forces will be unbalanced in the direction that it's going, or forward. And then the forces will be unbalanced in the opposite direction of the motion. Remember, if you're getting a push, what will happen to your speed? And this one is talking about if somebody is going the opposite direction of you, what's going to happen to your speed. 8. What is the net force acting on the object whose free body diagram is shown to the right? Remember, to determine the net force, you have to add up all the forces acting on the free body diagram. So make sure you look at all of those. Is it A, 1,000 newtons down, B, 1,200 newtons right, C, 400 newtons right, or D, 800 newtons left? On to page 2. Number 9. Draw a free body diagram of a tug-of-war in which Team B is pulling to the right with 700 newtons of force and Team A is pulling to the left with 850 newtons of force. Ignore the balanced forces of gravity and the normal. So it's asking you to draw a free body diagram of a tug-of-war in which Team B is pulling to the right, 700 newtons, and Team A is pulling to the left with 850 newtons of force. 10. Calculate the net force, including direction, for the tug-of-war you drew the free body diagram for above in question 9. So they want to know what the net force of this free body diagram of tug-of-war is. Make sure you include your label for the forces and the direction in which it would go. 11. The free body diagram below represents a sailboat sailing west. Which statement best describes the motion of the sailboat? So remember, this sailboat is going to the west. Is it A, the object is slowing down to the east, B, the object is slowing down to the west, C, the object is accelerating to the west? So remember, the sailboat is sailing to the west. Look and determine if the forces are balanced or unbalanced. Then, if they're unbalanced, is it unbalanced in the direction that it's going or opposite the direction it's going? 12. Assume the object below is traveling to the left. Which statement below best describes the object's motion? The balanced forces of gravity and normal are not being shown. You can assume that they're there. Alright? This is a little bit of a typo right here. This should say FD. So this is your drag force and this is your friction force. So what best statement below describes the object's motion? Is it A, the object is accelerating due to the unbalanced force in the direction opposite of motion? B, the object is slowing down to the unbalanced force in the direction opposite of the motion? Or C, the object is slowing down due to the unbalanced forces in the direction of the motion? 13. An hockey player whacks the puck with his hockey stick and sends the puck sliding across the ice. If you ignore the balanced forces of gravity and the normal, what are the forces acting on the puck after the player hits it? So, if you ignore the balanced forces of gravity and normal, what are happening to the forces on the puck after the player hits it? Is it A, friction with the ice and the applied force from the hockey stick? B, friction with the ice and drag, air resistance? Or C, friction with the ice only? "14. What are the forces acting on a baseball just after the pitcher releases the ball? How does that affect the ball's motion? Ignore gravity." 14. So, what are the forces acting on a baseball just after the pitcher releases the ball, and how does that affect the ball's motion? Ignore gravity. A, there are no forces acting on the baseball after it has been released, so it travels at a constant speed. B, there is an unbalanced force of drag on the ball in the direction opposite of its motion, so the ball slows down. C, the force acting on the ball from the pitcher is balanced by drag, so the ball travels at a constant speed. So what are the forces on the baseball after the pitcher releases the ball, and how does that affect the ball's motion? Ignore gravity. So you got to decide again, is it balanced or unbalanced? And depending on if it's balanced or unbalanced, what forces are acting on the baseball. 15. Which of the following statements correctly describes the motion of the object illustrated in the diagram below? So let's look here at the diagram, and they want to know which one correctly describes the motion of the object. Is it A, the object is accelerating to the left, B, the object is slowing down as it moves to the right, or C, the object is accelerating to the right? You got friction and drag here, so you got to remember which way does friction and drag go according to the direction of the object. 16. A skydiver jumps out of an airplane right after jumping. Gravity acts as an unbalanced force downward on the diver, so the diver, A, accelerates down towards the ground, B, falls at a constant speed, or C, slows for a while and then falls at a constant speed. So we want to know right after jumping, gravity acts as an unbalanced force downward on the driver. So this is unbalanced. So A, is the skydiver going to accelerate down towards the ground? B, fall at a constant speed? Or C, slows for a while and then falls at a constant speed? 17. Which of the following would increase the gravity between two objects? So we want to know what would increase the gravity between two objects. What would make them stronger? Would A, increase the mass of one or both objects make the gravity stronger? B, would increasing the volume of one or both objects make the gravity stronger between them? Or C, move the objects further away? 18. Which choice best explains how your weight would differ on Earth versus Mars? So, why would your weight differ on Earth versus Mars? Just a little bit of a hint, Mars is smaller than Earth. So A, on Earth, you weigh more because Earth is larger in mass than Mars. B, on Mars, you weigh more because Mars is smaller than Earth. Or C, a person would weigh the same on Earth and Mars because mass doesn't affect gravity.